Howdy there, Internet Geometry students. This is Mr. Hermanson again, and this is the frequently missed questions on the review, and I'm just going to quickly go over them, hopefully not spend too much time, unless I need to. So number 3, which lines or segments are parallel? And justify your answer. So here's what I'm seeing. I'm seeing that this line here and this line here are parallel because these two right here add up to 180. So we're going to use the converse of the same side interior angle theorem to prove that AB and CD are parallel. All right. I put this one on because a lot of people thought you could use side angle side. So I think you are thinking that these two are congruent because they kind of look like vertical angles, but they're not vertical angles. Vertical angles are from intersecting lines, which those certainly are not. It takes 3 segments to make that intersection point there. Not really intersection point, but anyway. So the theorem I am seeing here is that we have right angles and we have hypotenuse on those triangles and we have one leg. So I'm going with the hypotenuse leg theorem. All right. What type of symmetry does this figure have? It has reflectional and rotational. I think a lot of people thought it had point symmetry, but point symmetry would be if you reflect it across a point. Like if I reflected it there, you'd have a different orientation of this. So here's the easy way to tell if it has point. If it has rotational at 180 degrees, then it also has point symmetry. So this one has rotational, but it's 120 degrees, so it needs to have rotational at 180 degrees to have point. All right. What can we use to prove these congruent? Well, one thing that you should notice is that these lines are parallel, which means we have things like alternate interior angles are congruent. So really you have all the angles are congruent. And these are vertical angles, so they're congruent. So I think you could use angle, side, or angle, side, angle, which I don't have on there. So it would have to be letter C. All right. Up next, actually most people got A is a possible answer, but so is B. Saying both those is really fine. It's just a different orientation. So this angle right here, I think, is 41 degrees, and that's west of north. If you found this angle here, you'll find that it's 49 degrees, which makes sense because the two should add up to 90, and now it's north of west. So either A or B would be good on that one. I don't think there'll be any question like that on the final. Okay. What is the image of 2, -2? So that's this point right here. Rotated 270 degrees about the origin. Now remember that when you're rotating, you rotate counterclockwise always, unless it says clockwise. So we're going this way. Okay, if you went 90 degrees, and I can just draw in a line here. If we went 90 degrees, we would want to make this a 90-degree angle. So we would land there. And then if we went another 90 degrees, we would land there. And if we went another 90 degrees, we would land there. So there we are at -2, -2. All right. Remember on the final when you're writing an ordered pair to put in the parentheses. All right. I think some people got this wrong only because you would be going from the smallest to largest, and maybe you went from the largest to smallest, which is what I did. So I had to go back and change my answer. But so let's say this is our triangle ABC, and AB is not to scale. AB is 11, BC is 8, and AC is 14. Well, the smallest angle will be opposite the smallest side. So A would be the smallest, so that should come first. And then the middle one would be opposite the middle side would be C. And then the last one would be opposite the long side, which is B. So angle A, angle C, angle B. If two lines are cut by a transversal, so any two lines, let's say these two lines are cut by a transversal, then the alternate interior angles are congruent only if these two lines are parallel. Now these two angles would be congruent, but so only if the two lines are parallel. So we're going to say sometimes on that one. The diagonals of a rectangle are perpendicular. They are if your rectangle is squarish looking, because then it's a rhombus, and rhombus have rhombi have diagonals that are perpendicular. So we're going to say sometimes, as long as your rectangle is a square. All right, many people got this wrong, probably because you didn't remember this formula. You can find the area if you have two sides and the included angle by using this slick little formula. 1/2 AB, now A are your two side lengths, times the sine of C, which is your included angle. So in this one, we would do 1/2 times 16 times 12 times the sine of 74 degrees. Make sure your calculator is in degree mode when you do that. Okay. Number 39, we want to find the area of the shaded region to the nearest tenth. I'm just going to draw in this because we're going to need that. That's a little triangle. So we're going to find the area of the sector, which will be 1/3 because this is 120 out of 360. So 1/3 of the entire circle is the area of the sector. And then we're going to subtract the triangle, so minus the area of the triangle. Now there's a couple ways you could find the area of the triangle. If you knew, you have to know the height of the triangle there. Now, if you know how many degrees, which you kind of do because this is a 120-degree angle right here, right? So that little triangle, this is half of the whole triangle. Let me draw that again. It's a right triangle, right? This side's 18, and the height is right there, which is half of 18, which is 9. So we could do, and then the base, we would have to figure that out. That's 9 times the square root of 3. So, so we would have to do the base times the height divided by 2. Since this is half the triangle, let's just do base times height. So 9 times 9 times the square root of 3, which is 81 times the square root of 3. So figure out what that equals for your sector. Figure out what that equals for your area of your triangle. Now, one other way you could find the area of the triangle is that formula we just did, 1/2 A times B times the sine of C. So you could do 1/2 times 18 times 18 times the sine of 120 for your area of your triangle if you want. But then you have to subtract those two. All right. And this is just Pythagorean's theorem, right? So x squared plus 9 squared is equal to 3 times the square root of 13 squared. So x squared plus 81 equals, now I wonder if when you do this on your calculator, if you're not putting it in correctly or something, I don't know. But I would do that in my head. The square root of 13 squared is just 13, right? And 3 squared is 9, so this is 9 times 13, which is 117. And so then we're going to do 117 minus 81 equals 36. And so x squared equals 36, so that means x equals 6. All right. Find the length of mx to the nearest tenth. I think we're going to need some trig here. So we don't have any side lengths on this triangle right here right now. So we're going to have to get one of them. Let's get this side here, this y. On that right triangle, with respect to 38 degrees, we have the side opposite. And then y is the side adjacent. So we're going to use the tangent there. Tangent equals, the tangent of 38 degrees equals 34 over y. So y is equal to 34 divided by the tangent of 38, which is about 43.5. So, and I just stored that in my calculator under x. So now we need mx, so let's just call that x now. We know what y is, right? And we have this angle here. Y is now the hypotenuse of this. So we have cosine going on here. Cosine of 38 degrees is equal to the side adjacent over the hypotenuse. So that would be x over 43.5. So x is going to equal our y value is 43.5 times the cosine of 38. And that equals, I get about 34.3. All right. I think we're done. I hope you find that helpful, and hoping for the best on your final. Talk to you soon.